Welcome, Hornets, and thank you for joining me today. Today, we're going to be taking a look at assignment number 4 from the second term. This is found on page 324, and the entire problem's sets are 5 through 31 odds, 39 through 47 odds, 49 through 59 odds, 71, 72, and then 79 through 97 odds, finishing with 101 and 102. Now, we're going to be taking a look at just a few of these. So I'm going to be taking a look at some of the problems from each of these sections as shown. Let's make sure that we all see that. There we are. And these are the problems that I'm going to be working with. So the first problem that they ask us to do are working with the definite integrals, and they want you to use the fundamental theorem of calculus. Now, the fundamental theorem of calculus is by far easier than the limit process that we've been doing up to this point. So what we're going to do is we are going to find the antiderivative of 6x. We know that that is 3x squared, and we're going to put a bar behind it with a 0 below and a 2 up top. This is the notation for doing our fundamental theorem of calculus. We're now going to plug in our value at the top first. 3 times 2 squared minus 3 times 0 squared, and we end up getting 12. 12 is then our answer. Let's go to number 7. Number 7 has the integration from -1 to 0, and I have 2x minus 1 dx. Once again, fundamental theorem of calculus, we're going to have x squared divided by 2 times 2 is 1, and then we have minus x. We put our bar, -1 to 0. We're now going to plug in our 0, and that's going to give me, I'm going to do this in two pieces, 0 squared minus 0, and then minus, and we're now putting in 1 minus -1. Notice the double negative there made this a positive, and we have another double negative that's making a positive here. We then have 0 minus 2, and our answer is -2. Let's now go to number 9. Number 9 has the integration from -1 to 1, and we're looking at an even function, t squared minus 2 dt. Now, we have a rule that says if I have an even function, I can work at the axis of symmetry and simply divide it into two parts, allowing me to double my area. So that's what I'm going to do. I'm looking at this as 2 times the integration, 0 to 1, of the t squared minus 2. Using the fundamental theorem of calculus will allow me to have 2 times 1/3 t cubed minus 2t from 0 to 1. I now plug in the 1, and I have 2 times 1/3 minus 2 minus 2 times 0 minus 0. That piece goes away. This is the one we want to work with. This has 6/3 minus 1/3 is 5/3, multiplied by 2 is giving me 10/3. My answer is therefore 10/3. Number 11. Number 11 is giving you the integration from 0 to 1 of 2t minus 1 the quantity squared dt. Now, when you have something like this, all we can do is FOIL it out so that we have all of our terms. So we are looking at 0 to 1 of 4t squared minus 4t plus 1 the quantity dt. This is now what I'm doing the fundamental theorem of calculus on, working with my antiderivative. 4/3 t cubed minus 4/2 t squared plus t, once again, put your bar, and we're going from 0 to 1. Once again, notice the 0 is just going to go have everything go away. So we're looking at 4/3 minus 2 plus 1. Well, that's giving me 7/3 minus 6/3 is 1/3. And my answer is 1/3. Let's go to number 13, please. Number 13 now has the integration from 1 to 2, and I'm looking at 3 over x squared minus 1 dx. Now, we do not like having denominators like this. We want to change that into a negative exponent. So this is going to become 1 to 2 of 3x to the minus second minus 1 dx. This is now what I'm going to work with. So here we go. I have adding the power gives me a negative 1 for negative 3 over x, or x to the minus 1 if you prefer, minus x. From 1 to 2, and I'm now going to plug in the 2 first. Negative 3 halves minus 2 minus, plugging in the 1, I get negative 3 minus negative 1. Oh, pardon, minus positive 1. Sorry about that. I made us an error there and caught it. Very thankful. So I'm now looking at negative 4 minus negative 4 halves minus 3 halves. It's giving me negative 7 halves. I then have a minus, and this comes out to be negative 4. Notice the double negative here is going to make that a positive, and I'm now looking at negative 7 halves plus 8 halves. My answer is 1/2. And that's the answer to number 13. Let's keep going. So we're now going to head off to number 15, just so that we can kind of see all of the options that we have. Number 15 is the integration from 1 to 4. And notice they give me u minus 2 over the square root of u, du. We're going to start off by cleaning this up. We need to get two fractions, and that fraction has to have the denominator. So u over u to the 1/2 du minus the integration 1 to 4 of 2 over u to the 1/2 du. This is giving me 1 to 4 of u to the 1/2 power because I subtract. Notice I'm subtracting. This is 1 whole minus 1/2 here. And then this is coming up as 2u to the minus 1/2 power du. Now we're doing our fundamental theorem of calculus. Add 1 is 3 halves for 2/3 u to the 3 halves from 1 to 4 minus, this is going to give me 1/2. The reciprocal is 4. And then I have u to the, let's try this again. 4u to the 1/2 power, and the lights have gone off. Sorry about that, everybody. It's a little bit dark now, but that's because my district has lights that are on a motion sensor, not a timer. Aren't they joyous and wonderful? So here we have 2/3. I'm going to put in my 4. This is to the 3 halves power. Then I have minus 2/3, 1 to the 3 halves power. That's the first piece. Then I'm subtracting, and I now have 4 square root of 4 minus 4 square root of 1. And this is what I'm working with. Square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16. We're subtracting 2/3. And then we have 8 minus 4. This is going to give me 14/3. And I am subtracting 4. Now 4 is 12/3, so I have 14/3 minus 12/3. And my answer is 2/3. All righty, Hornets. That's number 15, and this is the end of part 1, and I will do part 2 in a moment as soon as I get the lights back on again. I hope this has been helpful. If you liked part 1, please make sure you hit like, or if you have comments, please make sure I see them. Thank you very much, Hornets, and please have a very good day, and part 2 will be coming shortly. Thank you.